Okay, angles in standard position. So, this first part of this lesson is basically a lot of definition stuff. So rotation angle is made up of two rays with a common endpoint called the vertex. That's good, you figured that one. I should actually just be able to pick this up and move it in, but I don't think that's going to happen. Oh, that's too black and thick. The two rays are called the... Yeah, we'll go with initial arm first because initial means like beginning, right? So the initial arm and the terminal arm. Terminal. An angle is in standard position. Here we go, the key to the whole lesson, right? If its initial arm is on the positive x-axis with the vertex at the origin. Let's say the origin. Positive angles are rotated counterclockwise. So do you all know how a clock turns? Because I mean, it's all digital now, right? So this is clockwise, and this is counterclockwise. Okay. So clockwise would be the way if we have a clock here. We don't have a clock here.
Yeah, it's right over there.
Ah, there you go. All right. So the way that the hands turn is clockwise. And positive angles are actually counterclockwise, okay? Which means starting at this, they're going up. And negative angles are rotated clockwise. So starting here, they would go down. As we rotate through, we have 4 quadrants. The first quadrant is named quadrant 1. I don't know why, but it's the first quadrant. So it's the first quadrant that we go to as we're rotating in a positive direction, right? So from 0 degrees to 90 degrees, quadrant 1. Quadrant 2, 90 to 180, and 180 to 270, and then 270 back to 0, or also 360 degrees, right? Which would be full circle. Depending on the size of the angle, the terminal arm could be in quadrants 1, 2, 3, or 4. Sometimes the terminal arm is on the x or the y axis. So terminal arm could be here or here. And in those cases, they are called quadrantal angles, right? And those angles would be 0 degrees, 90 degrees, 180 degrees, and 270 degrees. I don't know why I wrote that up. If theta, so theta is the x of trig, right? It's the unknown that we usually use. So you can use anything, but we tend to use theta. So if theta is an angle in standard position, then its reference angle is the acute, what's acute?
Less than 90.
Yeah, less than 90 degrees, right? So it's the acute angle formed by the terminal arm with the x-axis. Okay, and we're going to hit a bunch of that stuff. So for each angle below, or for each angle theta below, draw the angle and state its reference angle. Okay, so we're all going to draw slightly different, right? But it needs to be in a relative position. Okay, so if this is 0 and this is 90, I want 40. It's not quite halfway, right? So we'll call that, right? That's 40 degrees. So we're going to show the 40 degrees by going like this. So we're showing the rotation is from the positive x-axis, which is the initial arm, which is what makes it an angle in standard position, right? The initial arm is the positive x-axis. We're rotating counterclockwise, so it's a positive rotation, and we're going 40 degrees. And what is its reference angle? So reference angle is measured between the terminal arm and the x-axis. So what's this angle? 40, right? I mean, it's like, okay, so we're going to say theta r is equal to 40 degrees. 90 degrees. Okay, where's 90 degrees? Straight up. So we draw that there, and again, we show the rotation because we want to show a positive rotation, right? So we're showing it as a counterclockwise, and it's 90 degrees, and the reference angle will be 90 degrees. Really doesn't matter which way you go in this case, right? Whether I'm measuring to this x-axis or down to this x-axis, it's still 90. 165, where's 165? Which quadrant? Quadrant 2. Okay, and you put it approximately where you think it should be. Again, we don't have to be perfect. We don't need to pull out protractors and that. Right, we're just drawing a sketch. It needs to be in about the right position. I'll label these. Okay, what is the reference angle?
165.
No. It's acute angle, right? So it's got to be, what's acute? Less than 90. So it's the positive, it's always positive. So no matter which way you go, you don't think of I'm going this way, it's negative, or I'm going this way, it's positive. Just think, it's this angle in here, it's always positive, it's always acute, so it has to be between this x-axis and the angle. And it is, how much? 15 degrees. All right, so, okay, fire away. Finish off the rest. Or do the next three. So what you want to figure out is what quadrant are they in, about where are they, draw it, label it, show the rotation to get there, and then label the reference angle or state the reference angle. 251, where's that? Draw a straight line. I can't erase. This doesn't work like my board. And there's lag. Go. Yeah, I'm just going to calibrate. I think it's off a little.
That's an interesting sound.
Yeah, where's it from?
What?
No, it's just, got a text. It's okay. I can read it on my watch, though. I can read my texts on my watch.
That sounds really cool.
Can I see your text?
Let's see.
That's a pretty cool watch.
Yeah, okay. All right, so is that what you drew, pretty much? Okay, what are the reference angles? What's this reference angle? 71. Whoop. Okay, go back to the previous page, or it's just above. What's the definition of reference angle? Let's go back.
Always positive.
Okay, always positive and where? Reference angle is the acute angle formed by the terminal arm with the x-axis. It's not like it's like just right above where you're doing this now, so it's hard to see. I mean, for me, it's on a different page. I have to know. What's this reference angle? 90. Well, what's this reference angle? 37 degrees, right? Good? Yeah? Ready to move on? Oh my God. There's more.
Oh no.
Okay, now, how are we going to show 428 degrees? All right, so we're going to go around. Okay, 90, 180, 270, 360. Now, if I go another 90, how far will that be? 450, so that's too far. Okay, so this theta is 428 degrees. So I'm showing one rotation, like one full rotation of 360, plus another how much? plus another 68 degrees, right? So 360 plus 68. Well, what does that make my reference angle?
68.
68 degrees, right? Okay, so you can do H and I. Or can you do? Yeah, you can do H and I. So do H and I. Well, I try and figure it out. Okay, so 90, 180, 270, 360, 450. Yeah, so we could put little arrows on the terminal arms, actually, right? Because they go on forever. And 660. It's like a radio station.
I did.
Good one.
660. I've got lots of. 5, 6, 30. I don't have my eraser. And it goes black. Okay, and when we show the rotation, let's put an arrow on the end of the rotation just to show which way we're going, right? Because we're spiraling.
I think
Yeah, you do.
Eyes in the fourth one.
Eyes in the fourth quadrant. Oh. Oh, I can't erase with that. So, 91, 82, 70, 360, 450, 540, 630. There we go. Okay, so theta is 660. So what's the reference angle for I? 60.
What?
Well, what's the reference angle for here?
23.
And what's the reference? Oh, we did that one. Okay, so there. Is this good then? It's all good? Okay, how are we going to show negative 95 degrees? Okay, so we're going to rotate the other way. We're going to rotate the other way is clockwise. So theta is negative 95. And what's theta reference?
95.
Nope. Because it's acute. What's acute mean? Yeah, less than 90, right? So your theta reference angle says it's 85 degrees. Negative 200. What's there? No. Oh. Can't erase. Okay, arrows on the terminal arm. I'm going to go fix my terminal arms here. Make sure I got arrows on them. And negative 510. Okay, so we're gonna all drawn. Once you finish drawing them, we'll do the reference angles. While we're waiting, here's something else interesting about the watch.
Woo.
Yeah, how'd you know?
It does?
No, the watch isn't an iPhone. The watch is a watch.
Oh, where did you get this watch?
Oh, I backed it on Kickstarter.
Like Danny does.
Oh, really?
Yeah.
Same as Danny's watch.
Oh.
No, it's not.
Where did you get this watch?
I backed it on
Danny's watch is
Kickstarter.
an iPhone.
Can you go on YouTube?
No, on the watch? No. I can't actually do anything right now. Okay, so what's the reference angle for here? 20, theta r. Kickstarter. And what's the reference angle here? 30. Okay, Is everybody figuring out how to do reference angle? We're going to formalize it a bit in a minute, but you know, informally, you should by now kind of figured out, oh, okay, I see how this is done. But no? All right, that's all right. Okay, next, directions. These are called headings. Headings. And headings rely on the compass, right? What's at the top of the compass? North. What's at the bottom? South. Right? Left? Okay. So, on a compass, north is at the top. For a heading, the first letter says that's the direction that you're starting in. So it's as if we're facing east. And then we want to rotate 25 degrees towards the south. Okay? So this first heading, we'll do this, right? North. So you're going to start facing east and go 25 degrees towards the south. So this is east, 25 south. Okay? So that's one way in navigation of expressing a direction. Okay? The other way is with a bearing, compass bearing. What's north in degrees? 0. Right? And then positive rotation is actually clockwise on a compass, right? You go north is 0 degrees, east is 90, south is 180, west is 270, right? So it's kind of a little different than math, right? So we're not doing bearings yet. That's number 3. We're just worried about headings. Okay, so east 25, south. Express each direction as an angle in standard position. Okay, now, as an angle in standard position, now notice we put a restriction on here, right? We want it to be positive between 0 and 360, which means as an angle in standard position, I'm going to start here and rotate counterclockwise. And what is this rotation angle? Three 335, yeah. What's the reference angle? 25, right? Yeah. Because we started at the x-axis, right? When you're going east or west, you're on the x-axis. So whatever your rotation is going to be the reference angle. Now the thing about headings is this number is always going to be less than 90, right? You're not going to say go east and then go 180 degrees south, right? Why not just say go west then? Okay. So this angle will always be acute, less than 90. Okay, one more. We got south 62 degrees west. So we're going to start south, west, north, east. We're going to start at south. We're going to rotate 62 degrees towards the west. That is our heading, our bearing, or sorry, our compass, our angle in standard position. Starts at the positive, so we forget the northeast, southwest now, right? We say here's the positive x-axis. And theta is how much? 298.
Sure.
Really?
It's 208.
Yeah.
It was 180.
208. Yeah, right. So you got the idea, right? We're going to hit this when we formalize the, how do I get these reference angles, which are kind of mysterious to me now, but I'll take your word for it. Okay, so those are headings, right? Next we have bearings, right? We just discussed minorly, you know, we talked about it a little bit. So a bearing starts with north being 0 degrees, east is 90 degrees, south is 180 degrees, west is 270 degrees, and back to north, which could also then sometimes, you know, you could call it 360 degrees. So these are bearings, they're compass bearings, right? So say, you know, like put on here compass bearing. So express each bearing as an angle in standard position. Okay, so 23 degrees, where am I starting? So where do compass bearings all start? North. And we rotate clockwise. We always rotate clockwise, right? There are no negative bearings, right? Bearings are always between 0 and 360. We don't pull funny math stuff like, ooh, draw me an angle of 500, right? No. We just go between 0 and 360. Okay, so we got this 23 degrees. And what is our angle in standard position? Okay, so theta is 67 degrees. Okay, questions? One more. 300 degrees. Okay, again, north, east, south, west. 0, 90, 180, 270. So I'm going to go 300 degrees. I got to go how far past 270? 30. Okay, so there is my bearing, right, on a bearing of 300 degrees. As an angle in standard position, we start at the positive x-axis, so it's no longer northeast, southwest. Right now, this is the x-axis, this is the y-axis. We start here, we rotate there, and what do we get? 150.
Yeah.
Okay, all good? Next. What page are we on? Are we there yet? Are we done? Did we finish the first 2 pages?
Yeah.
Okay, all right. 2 down and 1 and 233. Coterminal angles. Draw these standard position angles 100 degrees. So on the first one, we're going to draw 100 degrees. All right, so no more headings, bearings, right? I mean, it'll come in. You can refer back to that. We're back to angles in standard position, right? Standard position. Why is every time you put the pen down? Okay, 100 degrees. 460. And this is 90, 360. 460 degrees. Remember, we're showing the rotation, right? That's how we show it's 460. Negative 260, negative 90, negative 180, negative 260, 820, 820. I was barely awake at 820. Huh. He acts surprised. Oh, you're not even finished writing. Okay, finish writing. I never let you guys. I never let you finish. Is this thing still recording?
I don't think so. It's just so much to say.
Oh well. Then I'll record a later lesson. Yeah, it's like it stopped. Did I pause it? I don't remember pausing it.
No, because when you did the calibration thing.
Oh. And we're back.
Dude, your hat's back on. Welcome back.
Like the new show. Okay, we're throwing it to you. You're the anchor. All of the angles above are coterminal, meaning that their terminal arms are in the same. That's called same position. Yeah.
It's already says position. It's
Oh.
the same position.
Oh, you were just reading.
Well, you can never be too sure of it. Well, the blank is too big, and the one for the origin was too small. Okay, are in the same position on the coordinate plane, but the amount of rotation is different. That sounds good. I'll go with that. The blank angles of the coterminal angles are the blank.
Reference angle?
Yeah, maybe. Okay, what's the reference angle here? What's the reference angle here?
80.
What's the reference angle here? Put a little subscripted R, right? 80. Okay, so now what are we going to say? The reference angles
Are the same.
of the coterminal angles are the same. We always say the same a lot. I think it lost communication with my watch, that's why.
Wait, so what kind of watch is
It's a Meta Watch Strata. We'll get it. We'll get it talking to the watch again. I may have to repair it. Ha! Repair it. Get it? That's funny.
That's so funny.
It is actually.
So funny.
Come on, repair. It's a Bluetooth device. I gotta repair it. Right?
Now I get it.
That's good, I think. Save for posterity. Okay, write one positive and one negative coterminal angle for each of the following. All right, so how do we get to be coterminal? Add more stuff, okay. Add 360, right? Or subtract 360, because that'll take us full circle, which means we're going to end up where we started if we go full circle, right?
Yeah.
Okay, so then you're going to add 360, right? Yay. I'm going to try repairing or connecting. Okay, so one positive angle, so 123 degrees plus 360 degrees is 483 degrees. And how do I get a negative one? Minus 360. It says connecting, but then it isn't. Yeah, I know, this does this. It's very annoying at times. I'm just going to reset it. I know, that was a good one, right? I think. What's 123 minus 360? Negative 237? Okay, negative 400 degrees. We want one positive, so adding 360 won't be enough. So what do we got to do?
720.
All right, so if 360 is not enough, we'll add two 360s. 2 times. And what's that? 320. 320 degrees. Don't forget the degree symbol, although for this, yeah, don't forget the degree symbol. And what's a negative coterminal angle? So you could go negative 40 degrees, right? Or you can go negative 4. How many coterminal angles are there? Infinitely many. Yeah, exactly. Infinitely many. Or as we like to say, lots. Lots. You're not allowed to say lots. Okay. Infinitely many then. Okay, watch. Now I can do this. Okay, ready?
That's the coolest thing ever. Plus, I love that song.
How did I know?
How'd you get it from?
I thought it was California.
Kickstarter, I told you.
Alexis, it plays a long time.
But where? What? Like,
All right, hang on. We'll pause. I never
we're back. Okay.
I never met a watch I didn't like. Okay.
Funny.
State. Let's wait as the joke works its way to the back.
We'll find out about
So there's a delay, right? Oh, I get it. Yeah. State, although the repair, that was good. State all angles beta coterminal with 126 degrees if beta lies between negative 720 and 720. All right, so what are we going to do? Okay, where did my... Yeah.
All numbers that hold it.
There's only two.
So we're going to start adding 360 until we get like to the point where we know that if we add another 360, we'll be over 720. And we'll subtract 360 to the point where we get if we, so, all right, apparently. My smartboard tools, that's a beta. Oops.
Oh, that's a. I thought it was a bird.
No, it's all Greek. Right? That's what I wanted. Okay, so
Oh my god. It just isn't working.
what's 126 degrees plus 360? 486. If I add 360 to that, we'll probably be over 720, right?
Yes.
Because if you add 300 to it, you'll be over 720. So, okay, we don't need to go any further. What's 126 degrees minus 360 degrees? Negative 234. What's negative 234 minus 360? -5, what? 94. And say no more, right? I mean, subtract another 360, but hey. All right, so those are all the angles. And this is the restriction, right? So we're restricting. We're saying you have to be between -720 and +7. Come on, give me my tools back. Write an expression for all angles. Oh, all angles coterminal with 126 degrees. So here's what we're going to write. 126 degrees plus 360 degrees, where n belongs to the integers. And what letter do we use for integers? Yeah, not Z. What are we, American? If you're American, you may use Z. Otherwise, it's Z. Yeah. Z. Ends it, right? X, Y, Z. Done. Right? Z sounds like it's still going on.
They actually, the only reason that they made that it's C in America is because they made it.
It rhymes with B.
They made it. No, that's why.
Oh,
To make it rhyme with the song.
The song.
They changed it.
Really? They changed it?
That's the only reason they changed it.
Seriously?
My brother did research on this.
Really?
He wanted to know. That's the only reason they changed it. To make it rhyme.
Well, I mean, it came from Britain, so they would have said Z, I imagine, to begin with. All right, the power of song. Number 7. State, which means what? When you state something, what do you do? Just write it down, right? You do not have to show how you got it when you state. What does determine mean? Show your work. Exactly. All right, so state one positive and one negative angle and an expression for all angles coterminal for each of the following angles. Okay, state. 70. 430. And what? Minus 290. And what's the general?
Plus 360 and
Degrees. Where n is a z, right? So any integer multiple, right? So you can have positive, you put a 0 in there, you just get your 70. You put a 1 in there, you get your 430. You put a -1, you get negative 290. You put a 1086, you get some other number which is coterminal. But okay, so you could do these two, right? And then just glance up and make sure I did them correctly, because
Yeah.
there's a good chance that it's not like I have a calculator. And I can't even get my thin purple line back. Although, I could go into the tools maybe. Okay, and, ooh, positive. Negative. Okay, is that good? Yeah, you get something similar?
Yeah.
Good. Yeah, it's easiest just to go for the obvious one, right? Like just add 360. You don't have to go for, you know, like unless. Yeah, exactly. When you give a pause, you know, so 1 billion, blah 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 blah, right?
I think it's still recording.
Yeah, it is still recording. You better hope the microphone's not really that sensitive. And that's why it went away at the bottom, but you can see the bar there now. Okay. Where is she? We haven't seen her for 2 days. Why did she abandon us? That's what you should be saying. We miss her. Go ahead. We miss her. She's not going to watch this, though. So.
Oh.
Let's just put it up on flash.
Nobody's actually going to watch this. It's like, you know.
It's always
Okay, let's finish.
Do it backwards?
The, you want to know, you could watch it. The reference angle of theta, an angle in standard position, is shown. State the value of theta which is not the reference angle, right? So the reference angle of theta, so there's some angle standard position. We're giving you the reference angle. We want to know the value of theta if it's between 0 and 360. And we often call that the principal angle. You know, P-R-I-N-C-I-P-A-L, like the guy who sits downstairs. The principal angle is the angle that's between 0 and 360, right? Because we know there are infinitely many coterminal angles. If we all want to be talking about the same angle, we want to talk about the one that's between 0 and 360. Okay, so what is theta? 78 degrees. You got to love those first quadrant angles, right? Because they are what they are. What is theta? 100 and?
45.
What is theta?
250.
And what is theta?
342.
Okay, so does everybody know how we got those numbers, or you know, or whoever it is that was saying them, because it was one person just giving me all the numbers? So if we're in quadrant 1, the reference angle is the rotation angle, right? Is the principal angle. All right, so if we're in quadrant 1, if you have a reference angle of 50 degrees in quadrant 1, which I'd like to draw out, but it's going to be like a thick black line again. I want my thing back. Give me my smartboard tools. Should be a little slidey out menu from the side. It's like everything's messed up here. No, whatever. All right. So a quadrant 1 angle reference angle. So I have a reference. Whoops. I have a reference angle of 50 degrees in quadrant 1. So we might want to draw it out. Okay. You can draw much thinner lines, I'm sure. And what are we looking to do here? I guess we're looking to state the quadrant 1 angle. So the quadrant 1 angle is 50 degrees. If I have a reference angle of 50 degrees in quadrant 2, okay, so let's say this is theta r is 50 degrees, and theta r is 50. I gotta change this pen.
Pink
Some
one.
properties somewhere, right? Edit, maybe edit. I love these smart boards. All right, what's the angle? Rotation angle?
130.
So theta equals, I guess here we should write theta equals. So 130 degrees. Make my pen thin. Line property somewhere.
What about that other pen? The sparkles on it.
Yeah, I'm sure that will just give a really thin little line. The other pen with smart note. What? What? What is that?
There's 3 pens up there. Pick one of them.
Yeah. Okay. So
Oh, now it's blue.
that's blue.
Alright.
Whatever. Oh, now it disappeared. Oh, that was the disappearing ink. That's why. Okay, quadrant 3, I have a reference angle of 50 degrees. Theta r is 50 degrees. What is my rotation angle? 230, right? 230. It's the time you go to the dentist. Get a million. Does Tom tell jokes?
Nope.
No, really?
She tells really good jokes about acute angles.
Oh.
Yeah.
Like acute.
They're just like you. They're so cute.
She gets really excited over flagpoles, though.
Flagpoles. Oh, indirect. How do we just climb up it and drop down a line? Except, you know, you have to fill in all the forms from the board. You know, dangers could fall. 38 degrees. Oh, I hate this. Okay, I'm gonna pause this. All right, we're back. 38 degrees, yeah, and we're back.
Yay, works.
Theta r is 38 degrees, and the rotation angle is 38 degrees, right? It is what it is. In quadrant 2, we have a reference angle of 38 degrees, and our rotation angle is, or our angle in standard position. Right? 142? Right? Yes, no, maybe, I don't know. I'm just guessing here. And theta is 218 degrees. And theta is 322 degrees. And so now the ultimate, right? The general. So we've done two specific examples, right? So in general, this is theta r, and our rotation angle is theta r. Okay, so remember the theta here refers to the angle in standard position, or I'll call it the rotation angle. The theta r is your reference angle. In quadrant 1, theta is equal to theta r. In quadrant 2, here is my reference angle, theta r. What is theta?
180 minus theta r.
Yeah, 180 degrees minus theta r. So when I'm doing this, for myself, right, usually I just say to myself, how much further do I have to go to get to 180? Now, right, so if I've gone 150, then I need to go 30 degrees further to get the reference angle. Because you can rearrange this, of course, right? So you could say that theta r is equal to what? 180 minus theta. So if you want to work out the reference angle, you could say, I can take 180 minus theta. What I do, which we all end up doing, but if I say, hey, my rotation angle is 150, then I usually say, if I go another 30, I'm going to hit 180. Right? What am I really doing? I'm really subtracting 180 minus 150 to get that 30. But. Okay, we go into quadrant 3. And here's that. And what is theta?
180 plus theta r.
Yeah, 180 plus theta r, which could be rearranged to say theta r is equal to what? Yeah, theta minus 180, right? And quadrant 4. What is theta? (360) minus theta r, and what is theta r if I want to write that? Yeah. And here, theta r is equal to theta. So now we have expressions, right? Which you're never going to use because you don't need to, right? You just sketch it out and you just say, so if I'm in quadrant 2, I usually just say, how much further do I have to go to get to 180? If I'm in quadrant 3, it's how far past 180 have I gone? If I'm in quadrant 4, it's how much further do I have to go to get to 360? That's what I always ask, right? I mean, you'll figure out your own way that works for you, but that's basically the whole idea behind the rotation angle or the principal angle theta and the reference angle theta r. Okay, and then